Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Hey everybody, welcome to Beyond the Bench, Hardware Stories That Matter. We have a fantastic episode for you today. Thomas Petazzoni from Bootlin. Welcome to the show. Thanks for coming on.
Thank you very much for having me on the show.
Absolutely. So what's your role at Bootlin?
So I'm currently the co-owner and CEO. So my journey started at Bootlin in 2008. I was the first employee to be hired by the founder, who was Michael Obdenacker. And then the company started growing up to the point where by 2012, 2013, I became CTO to manage the engineering team. That was growing. Maybe at the time was not very large, maybe 6-7 people or so.
Mm-hmm.
And then in 2021, together with another colleague, we did acquire the company. So the founder, the original founder, is no longer in the team, but two former employees, me and Alexandre Belloni, are now the owners and are running the company. So it's two people from the company who were formerly engineers doing embedded Linux kernel work, who now own and run the business. We are now a team of 26 people as of yesterday. Another guy joined our team, and we're still doing embedded Linux and Linux kernel work.
You are one of the premier shops in this space and the embedded Linux space. And how did you get into this? So would you even consider yourself a Linux guy when you started way back in the day, or what was kind of the on-ramp for you? You've seen a lot of change.
Definitely a Linux guy from a long time ago. Like back in high school, I was already interested in system programming. For some reason, someone when I was in high school told me you should learn C. So I was like, okay, let's try to learn C. So just to make sure the audience knows that, back when I was in high school, like internet was a thing, but like barely accessible, right? So I had to buy the Kernighan and Ritchie book and learn C, let's say what we could call today the hardware, I guess. And once I had learned like the very basics, I was like, okay, I need to do something. And so I set as a goal to write an operating system, because of course, why set a small goal rather than an ambitious one? So here I was 15, 16 years old. I was like trying to write something that is an operating system, and I actually did it not alone. I ended up meeting a couple of folks on the internet, news groups, which were like the communication system of the time, and that's how I got into system level programming. Like so, I always did low level stuff. Right, got interested into how computers boot, how they work, how you do multitasking, how you manage memory, how you interact with peripherals, with hardware, how you write drivers. I've always been in that space. So then I went into what we call in France engineering schools, which are like universities but dedicated to engineering. Mm-hmm. And it took computer science. I graduated in 2005. Then and did of course Linux was my.
How much of the school was? Did you already know? Like, was the first 2 years just a total breeze, or were you actually filling in the gaps?
Yeah, so it's 5 years. The first 2 years are very general, even for people going into mechanical engineering, computer science. So it's very general. So it's mostly math, physics, chemistry, and things like that. So that I had to follow because it wasn't a lot of computer science stuff. Then when we went into computer science, of course, there's a fair bit that I already knew, but also some other stuff that I didn't. So it wasn't very challenging, of course, because of my background, but I still did learn a lot. And I think it's not only about knowledge; it's also about like building a bit of experience, communicating with people, doing projects in group, stuff like that. The non-technical stuff is also really important. I remember having like lessons in accounting, in law, in other things than computers that also matter even today, especially considering my role today. These matter as much as computer science does matter, at least for me. So then, when I was out of school, I got a first job doing Linux kernel work. Sadly, it wasn't open source, but I immediately got into kernel stuff. And after a few years, I was hired by Bootlin, and I've been there for the past 17 years. or so.
So did you have any like embedded experience with this prior role, or was that something that you jumped into with Bootlin?
So that prior role, no, it was really like kind of the opposite of the spectrum. We're working
Mm-hmm.
on computation clusters. So it was still Linux based, running Linux kernel, but really like big, heavy machines with lots of
What year was
CPU,
this?
lots of RAM. Mhm.
Around what year?
I was there from 2005 to 2008.
Okay.
And it was a French startup trying to develop a distributed storage system based on Linux for compute clusters.
Cool.
Was really interesting, technically speaking, but it wasn't open source, so it was kind of fitting only half of what I wanted to do, to be honest. But then prior to that, I did quite a bit of embedded during my internships, and also my system level background made it kind of easy to jump into embedded. Even though I really have more of a computer science background than an electrical engineering background, clearly.
Yeah, I went to school, master's in engineering, and it was heavy computation focus, and we had like a cluster at the school, and there's a lot of parallel programming and all of that. And I always remember being so impressed with the electrical engineers that were in my program because they had such a foundational understanding of like the memory management and parallel. There's like math and physics and like circuitry, and I'm like, man, if I could do it all over again,
Yeah.
he is like totally the way to go. Yeah.
Absolutely. And what I remember being really impressed when I was doing one of those internships, and I'm still impressed by that, is how the people doing electrical engineering do design that have to work from the first iteration. When we do computer programming, we iterate like zillion times trying to get something to work. They don't get that chance, right? When they do like a PCB design, they do a design, they have to think about it very carefully. And then when the PCB design goes out to the fab, okay, they can do maybe 2-3 iterations, but that's pretty much all what they got.
Yeah.
So they really need to be super careful. So I was and remain still really impressed by how this is different than the traditional software development style where we try something out, doesn't work, we change things a bit, try again, and it may be that within the course of a day we try, I don't know, 10, 20, 50 times to run something to get it to work. In electrical engineering, they can do that, 2 or 3 times per project or something like that. It's pretty different methodology, definitely. That's quite impressive.
And how close? So we'll back up really quick. So what's the elevator pitch on Bootlin for those that don't know the name?
So we are a consulting company specialized in embedded Linux development. That's kind of the one sentence summary of who we are. So we provide engineering services where we help our customers basically put Linux on their hardware. So we port Linux to new hardware, we write drivers, we port bootloaders, we also write the drivers in the bootloaders. And then on top of that low-level development, we also do a lot of what we call embedded Linux integration, which is basically putting together optimized Linux systems for embedded devices. Because for most embedded products that run Linux, you don't use a desktop system like Ubuntu or Fedora or Debian, but you build a tailor-made image with something like Yocto or Buildroot or OpenWRT. That really fits and contains just what you need to reduce the footprint, but also make maintenance easier and stuff like that. So we also have a lot of knowledge in using Yocto, using Buildroot, using OpenWRT, and basically integrate all the open source stacks that our customer needs. So typically our customers the type of services, they do embedded products, so they design their hardware. They want to write applications, but they need someone having the knowledge of what's in between, all the system level stuff. How does the system boots, all the drivers, then how to do, for example, updates over the air. That's, I think, a good example. Security with secure boot, encryption, all really the system level stuff that requires some pretty strong Linux background. We help our customers with. So that's really the engineering services side of what we do. And then that's about like 75% of our business, and then 25% of our business is doing training courses on really exactly the same topics: embedded Linux, kernel drivers, Yocto, Buildroot. We have a few more advanced courses like real-time debugging. And in both cases, I think that what makes us perhaps stand out quite a bit from other companies doing the same is that we are really, really strongly open source focused. Our training courses are all open source, like all the materials are freely available. Anyone can download them, all the slides and so on. And it's been like that since the inception of the company 20 years ago. And even on the engineering services side, we are very strongly connected to upstream open source projects. So we contribute a lot to the Linux kernel, to Yocto, to Buildroot. Like every single kernel release has patches from us. Every single Yocto release has patches from us. We even have people in our team who are maintainers of some smaller parts of the kernel or maintaining different parts of Yocto or other projects. So we're really not just consuming open source, but also actively contributing, participating to, of course, the few open source projects that are relevant in our space, right? Not the full landscape of open source, which is really gigantic, but the one in our ecosystem is we're actively contributing to. So I think that's really the pitch of what we do and how we help our customers.
And you mentioned early on that this was important to you into your career. So, like, how influential were you early on with Bootlin getting involved into open source, or was that already a cultural foundation and part of what excited you to get there?
Yeah, it definitely was part of the cultural foundation. So when Michael, the founder, had set the company, he was really deeply convinced by open source. He's really a free software person. I actually met him through free software open source conferences here in France. So when he started, he was mostly doing training. And from the start, he decided to share the training materials openly. So that's really deeply rooted in the company culture. And so when I joined a few years later, I did start the engineering services side of the activity. So we kind of expanded that DNA of being strongly connected to open source to our engineering services business. Of course,
so what was the original business? So the original business was just getting paid to maintain open source?
No, the original business was delivering training courses. That's really the where it all started. Okay. And then when I joined, we're finally two. We could do a little bit more, and we expanded into doing engineering services.
So you 100% improvement on output with two people.
Exactly. That's a big step for a small company, right? Jumping from 1 to 2 persons.
Yeah, awesome. So a lot of our listeners, so we span a wide gap, but we have executives, we also have engineers, VCs across the board. What is another softball, and then we'll get into more deep topics, but where all is embedded Linux? What is this is a hugely important part of the world that you're working in from our perspective, like Yocto, embedded Linux. Like for the common person, when you tell your aunt what you do, how do you explain the breadth of the impact that you guys have?
That's of course a tough question. First of all, I think what people don't necessarily realize is how much computers they are around them, right? They usually think a computer is that thing that sits on your desktop where you do like email and YouTube and stuff like that. But they really think like that the TV is a computer, your Wi-Fi router is a computer, your alarm system in your house is a computer, your home automation system, your AC control thermostat is a computer, your X-ray machine at the hospital, your all the machines at the hospital are computers. They are in a plane, in a car, in a windmill, and really everywhere there are computers, right? It's and I'm still amazed. I've been in this business for quite a long time, and I still see customers coming to us and having like use cases that I had never heard of, machines that I didn't know they would exist, right? Strange machines for doing agriculture, industrial stuff. It's amazing how wide the landscape of places where you find a computer is really. It's really wide. And so all those computers that are embedded, hence the name, right? They are deeply embedded into a machines where we don't really even realize there's a computer. They need software, those computers. And that's the embedded space. And in that space, which used to be mostly based on, like, say, custom grown software most of the time. That's what we were using in the 80s, 90s, early 2000s, mostly custom grown. A few proprietary operating systems would be used. But then Linux, which is open source, has become a big player in that space. mainly because those computers embedded into different systems needed to be more and more complex with connectivity needs, multimedia needs. I think these are the main two things that drove the adoption of Linux. And so Linux is open source. Everyone has the source code. We can adapt it the way we want. And that's exactly something we need for embedded, where we need a lot of flexibility to design something that exactly fits what we want to build. And so that's what embedded Linux basically is. Take this open source software and tailor it to make it work in an embedded device that will then operate a machine that is in your home, at the hospital, in your car, in your plane, in whatever industrial machine you can think of. There's really millions of applications of Linux in the embedded space.
And when we were first getting into this space and focusing on devices, it wasn't always clear how to target the right segment, because there's like microcontrollers and sensors and like really low power things that are not. And there's some compute, but I wouldn't call them computers. And then there's like edge gateways and just full on like set-top, like buy a computer, throw it in a closet, and you can run that Ubuntu OS. And so how do you think about when is Yocto and embedded Linux the right solve for a given problem?
I would say, so of course, microcontrollers, they usually, at least today, don't run Linux. They would run something more lower end, like a bare metal code or Zephyr or FreeRTOS or some other like smaller real-time operating system. So definitely Yocto isn't really designed for that. On the other side, when you have something that is really general purpose, like you would a smartphone, for example, or a tablet, Yocto wouldn't really be a great fit. I mean, it can be made to work, but it's not really a great fit. I think it's a great fit for pretty much what's in the middle. So systems that have the hardware capabilities to run Linux, typically a microprocessor rather than a microcontroller, but also systems that are not general purpose, that are custom designed to deliver a particular feature or set of features that is well defined. Rather than something where you want to install random apps like you would do on your phone or tablet or desktop computer. So that's where Yocto fits, and it can really then address a wide range of needs from relatively low-end systems that have, I don't know, a single core, a little bit of RAM, not much storage, all the way up to fairly strong embedded devices that have a lot of computer power, maybe AI capabilities, maybe video encoding capabilities. So it's really a wide range of systems that can be covered by Yocto or even other solutions like OpenWRT built, which really are pretty much offering the same kind of feature set.
Got it. What is like broadly in the industry? What's holding us back right now? Like, what do you view are some of the pain points that we're experiencing in embedded Linux space?
Yeah, so to me, the main pain point, and it's been pretty much the same pain point for the past 20 years, is cooperation from the hardware vendors, as and always remains a challenge, right? Getting documentation on the hardware that they provide. A lot of hardware aspects have remained undocumented or under-documented for some parts. And the other aspects is having them more engaged into upstream collaboration, where those vendors, mainly the vendors for microprocessors, SoCs in the ARM or RISC-V space, should engage even more with upstream projects. We have helped a number of silicon vendors at Bootlin getting engaged into Linux kernel and U-boot and other upstream projects. But definitely this is the part that is still not perfect. It has improved vastly compared to where it was 15 years ago, but we still have a lot of platforms, processors that are lacking in terms of upstream support, which means we have to use kernels, bootloaders that have been heavily patched by hardware vendors, making them difficult to maintain over the long run, making them difficult to understand, sometimes using non-standard interfaces and other issues. So I think that remains the main pain point, at least for what we do in the embedded Linux space. That remains the main pain point. There are probably many others concerns, but when it comes to what we're doing with our customers, that's really I think the number one issue is documentation on hardware and upstream software support.
I won't make you say who has the worst Linux, but what vendor, when you pull in a project, you're like, yes, we can really cruise here. This is good Linux.
Yeah, so there's definitely so I don't want to do too much like who's bad, who's good.
Exactly, yeah.
But ST is doing really a great job on their STM32MP platforms. Microchip has always been doing a great job upstream. NXP has been improving. Their upstream support is pretty good. But historically, mostly not because of NXP or back in the days Freescale, but because of huge community collaboration.
Right.
They're lucky enough to have a really broad community of users, developers that have kind of filled the gap over time. TI is also actively engaged upstream. They have complex SoCs, so they require a lot of software support, but they're really strongly engaged in upstream. As usual, they could probably do more. There are parts of older TI SoCs that are still not supported upstream, for which no documentation is available, so they could do better, but I think, ST, Microchip, NXP, TI are doing a pretty good job. And they're widely used in the industrial embedded space, right? So, which makes sense because a lot of those products have not very high volumes of production, so they don't get direct support for the silicon vendors. So it's really key for this type of projects to have great support in upstream in the community. Unlike projects that ships in, let's say, millions of units where you can get direct support from your silicon vendor. And in that case, you don't necessarily care that much about the community support because you get direct support from your hardware vendor. But not everyone has that because not every project ships in millions.
Got it. Okay, that's an interesting way to think about it. Very cool. What are the domains that you typically operate? So you mentioned industrial embedded space. We share a customer that was doing some power distribution unit, kind of purpose-built networking hardware. Like, what are the industries that you find yourself operating most frequently?
It's really across the board, really, because our knowledge is kind of horizontal, I would say, compared to like vertical markets. When we do write a driver, if we write, let's say, I don't know, a camera driver, whether that camera is going to be used in a car or in a medical application, the Linux camera driver is pretty much exactly the same. So we have customers in healthcare, in all sort of industrial application, in some more consumer grade applications as well. So it can be systems for sports, gaming, deeply industrial things. We have a customer doing, I don't know, seismographs, some other doing power distribution units. We have a customer doing communication devices for air traffic control. We have customers doing devices to count points in bridge games. It's really all over in terms of application domains. We have a customer doing systems to distribute audio in shops, airports, train stations, all those audio communication for the passengers and stuff like that. So it's really, really everything. And as I said in one of earlier in our discussion, sometimes we are ourselves surprised to see, whoa, this is running Linux, right? It's pretty amazing to see where Linux is running these days.
Have you ever considered developing any products yourself, or are you truly passionate about the consulting and open source side of this?
No, we've never really considered building a hardware product. I mean, we have a few of our own projects at Bootlin, a few open source projects, but we never considered building our own products.
What are some of the projects that you've launched?
So I think the main two ones that I have in mind is, the first one is Elixir, which is not the best name in the world because there's also a programming language called Elixir, which makes it confusing. But our Elixir is a website that indexes the Linux kernel code base, which perhaps our listeners know is quite large. So navigating into the Linux kernel code base is challenging. So from the web browser with Elixir, you can follow function calls, type definitions, and so on. And so the reason why it's called Elixir is because back in the days, there was a piece of software called Elixir, which was doing exactly this. But it was kind of old-fashioned, written in Perl, got very slow with the increase of the kernel size and so on. So we kind of rewrote a number of years ago the piece of software with Python, more modern database, relying on Git. And we host that on elixir.bootlin.com. And now we've expanded not only at indexing Linux, but also U-Boot, Opti, ARM Trusted Firmware, QEMU, Xilinx, and a couple of important open source projects in our space. And it's a pretty popular tool. We managed to keep it like fast, light. So people tell us they like it.
Cool. It's the first I've heard of it. Yep. Yeah, we'll take a look. Yeah.
So that's one project. And the other I had in mind was launched more recently. I think it was a year or two ago. We released something called SnackBoot, which is a open source vendor neutral tool to recover embedded platforms. So I guess that needs a bit of explanation, but most of the embedded hardware that we use, at least to run Linux, has some sort of built-in protocol to communicate with the processor to recover if the device is in a faulty state, like if it's bricked, or if the device is not flashed at all. So we need a way to kind of create life, and that's usually through a custom protocol specific to each hardware vendor. And to interface through that protocol, usually every hardware vendor ships its own software that you run on your PC as a developer to flash your embedded target. And we found it really annoying that when you were doing a project with a platform with vendor A, you had to use given tool, then another project with vendor B, you had to use different tool. It wasn't really like the mindset of open source, right? You use Linux, the same system on all hardware. We wanted the same to reflash, recover our embedded targets. So that's exactly what we did. One of my colleagues wrote a tool that is now capable of doing the recovery, the reflashing of TI, ST, Microchip, Allwinner, NXP, some of the Zinc MP platforms from Xilinx, all in one tool. So regardless of the target you want to work with, it's the same tool, the same configuration, interface, and so on. So that's the other project that we launched.
Is this something that is more commonly encountered in like development scenario when you're trying a lot of different approaches, or maybe switching from one product to the next on the same like development kit, or is this something that you would actually use in the wild, like post-launch?
So no, it's definitely not used post-launch. So the initial use case was really for the developer. You're developing as an embedded target, you're prototyping, developing your product. That's where that's what it was initially targeted for. But last year we got some sponsoring from one of our customers to extend it to a more let's say feature complete factory flashing solution, where end of the line, when your hardware is produced, you need to flash something on devices to make them work. And so we expanded it to be able to flash in parallel an arbitrary number of devices with a monitoring interface that allows to follow the progress of the flashing process for multiple boards in parallel, which clearly wasn't the initial target. Initially it was really like, I have this one board on my desk that I want to recover. But now we're really expanded to like, I can have a PC that does the flashing connected to 10, 20 boards at a time that get all flashed in parallel. So this is the other use case, but that's definitely not used in the field. It's really either on the embedded developer workstation or on the factory floor to do the factory flashing of devices.
Cool. Very cool. Hard pivot. So everybody is excited about accelerators, AI in the field, neural processing. How difficult has that integration been for you, bringing customers up to speed to take advantage of these NPUs? Has that required a lot of custom work on your side, or are the vendors really providing good software for those interfaces?
So far it hasn't been such an issue for us, because even if AI is all over the place, it's still not yet all over the place in all embedded applications. There are a lot of embedded applications that don't need AI, they don't need accelerators. So it's still an issue that we haven't really faced. That being said, on the software support from hardware vendors, I think we are really like circling back to our earlier discussion on what is the main pain point. And the main pain point in that space is lack of documentation from the hardware vendors. So it's we're in the NPU space. My feeling is that we're pretty much where we were in the GPU space 10 to 15 years ago. We're using
Back to the beginning of your career.
Exactly. Where to use a GPU and have OpenGL acceleration, you always needed to use a closed source binary blob that was always causing problems because it could only work with that specific kernel version, or would have bugs, or would not work with the latest graphics stack in Linux, would always cause to some degree problems. That has been on the GPU space has been mostly solved thanks to a lot of reverse engineering work from community developers, but also collaboration from some other vendors who finally understood that it was actually much better to do it all in open. But I think this history repeats, and we're seeing kind of pretty much the same mindset from other vendors with NPUs. It's pretty secret, not very documented. There's also reverse engineering effort ongoing with some really, really good work being done on some specific NPUs. But so far, for the specific projects that we do, this has really been a concern because, again, AI is not necessarily everywhere, even though the news might make you think otherwise.
Even though it's everywhere we look, it might not be on the devices quite yet.
Yeah, exactly.
Yeah. Where is AI going to help you in your day-to-day job? Do you see there being opportunities to, it's easiest to write, React and front-end code with AI because there's the heavy volume of training data. When is it going to actually make your life materially more
So
I don't know, easier, lower the bar for embedded development for Yocto people?
Yeah, indeed, I don't think it's really going to help us, at least in the current state of the art, right? Yeah. I want to be very cautious because what I could have said 2 years ago on that topic would be wrong today, right? So I'm kind of really be cautious on that. But as of the state of the art of today, my feeling is that AI is not really going to help us write like drivers or low-level code. I don't think they yet have like maybe the volume of training data or the understanding or the ability to really read a datasheet, schematics, and sometimes even a human person does not have all the information needed, and you need to do some guesswork to like extrapolate. Okay, the datasheet says that maybe this is what they meant, maybe this is how it works. So we have to kind of be really creative when we try to bring up some hardware to life. So I think AI is not really going to help us with that today. However, it definitely can help and does help in doing code review, pointing, let's say, stupid, silly mistakes in the code. It also helps, and maybe that's something not so important for an English native speaker, but for people like us who are not necessarily English natives, having something that proofreads English comments, commit messages, that polishes them a bit is very, very useful. So that's kind of more on the side. I think the main activity, which is really like understanding how the hardware works, reading datasheets, writing the code that tinkers with the hardware, or writing Yocto recipes, all of that sort of stuff can be maybe partially helped with AI, but not too much. But to me, it's really activities around that can be helped, accelerated with AI. And interestingly, 2 weeks ago, there was a conference in France, Embedded Recipes, which I don't know if you've heard of.
Yeah, I saw them.
And there was
that a good show?
Sorry?
Is that a good show? Good conference?
It is definitely, yes. It's a spin-off from Kernel Recipes, a very like unique format, single track, one room, with like limited attendance, like 150 people. So it really allows to connect with people a lot more than larger shows like the Open Source Summit, for example. And there was a talk on using AI for embedded development. And precisely the speaker was kind of reporting on how AI helped him on some embedded projects. And it wasn't so much on coding the firmware code itself, even though he used it for some specific parts, but it was really a lot about activities around writing the documentation, writing additional test cases, doing proofreading, stuff like that, which were really accelerated using AI. So at least that's where I see it potentially fit in our space right now. But of course, in 2 years' time, who knows what AI will be able to do for us.
Yeah, I don't think we're vibe coding our bootloaders anytime soon. But
No, not yet. Exactly.
a little too important.
Yeah.
But it does beg the question. I mean, these are critical systems, and a lot of the use cases you're talking about are like healthcare and, like a Siemens scanner or something, like go lay on a bed, there's a computer in there. I mean, at some point it is going to be like what Elon's always said about the self-driving is these systems are so critical. Why have humans drive? If we could trust the robots to do it, then we should. But writing software is a little different than we're driving a car is hard, but writing software is a little different.
Yep, absolutely. Yep.
Awesome. Well, I've really enjoyed this conversation. Before we close, what are you looking forward? What are you most excited about coming up in the embedded Linux space or the community, or what are you looking forward to this year?
Well, this year in particular, still hoping for more collaboration from other vendors. I think that's really one thing. I'm interested to see where RISC-V is going.
Cool.
Right? It's been around for some time, but I still yet don't see it really appearing in the projects of my customers. They are still mostly ARM-based, some x86, but mostly ARM-based. So it seems like the case for RISC-V is not there yet for the deeply embedded systems. Maybe in the data centers, they are making more.
And what are the benefits of RISC-V? Why are you excited about RISC-V?
Well, first because I think it's great to have competition, right? Open source is all about competition and having multiple players, and that's sane for everyone, right? To make sure that there's no one player that does it all, because when that's the case, it's never a good sign for progress, for technology, for price, for a lot of things. So I think just having competition is by its own a good thing. And obviously the fact that RISC-V is open, it's a free instruction set architecture, allowing companies to innovate with a common base that is shared, makes a lot of sense, is of course appealing to me as an open source person as well from a value perspective. So that's mostly what excites me about RISC-V in general. But it still has to show up in the industrial embedded space and to really make the case for being better in this field than what already exists.
Do you think it'll get there? I mean, that's how Linux came about, was open source, and it eventually lapped Microsoft, and now it's everywhere. Do you think RISC-V is that?
It's hard to say. It's really hard to say. 3-5 years ago, I would have said definitely yes. And now I'm like, the progress is somewhat slower than what I was expecting. So I don't want to make really any bets on what the future is about, but it has been slower than my expectations, right? Maybe it's normal, right?
Hardware's a little slow, typically. Yeah. So not sure when, but I'm pretty sure it's gonna make progress, right? Because it's relevant to have a competitor against what is the dominant CPU architecture in the embedded space. Sure. Well, awesome. Well, really enjoyed the conversation. Thanks so much for coming on. And for those of you that enjoyed the episode, you too can work with Bootlin. Just check them out. It's at bootlin.com.
Thank you.
Yeah. All right.
Thank you. Bye-bye.
Well, thanks a lot, and have a great week.
Thank you very much. You too.
All right, everybody. Just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.